This is the review for the construction test and equation of circle tests. I'm going to try and go through this as fast as I can. So starting with number 1, write the equation of a circle. And we have to identify where that center point is and what the radius is. The radius here is just 3. The center point itself is at -1, -1. So we have to write it in the equation of a circle formula. So we're going to have, first, our equation of a circle is x minus h squared plus y minus k squared equals r squared. That's what we're plugging it into. So on this one, we have x plus 1 squared plus y plus 1 squared equals 3 squared, which is 9. Then on the second one, same thing. You have a radius of 4. You have your point at 3, -1. So when you write your equation, you have x minus 3 squared plus y plus 1 squared, and 4 squared is 16. This one, they give you the center and the radius, so all you have to do is plug it straight into your formula. X minus 4 squared plus y minus 5 squared equals 8 squared, which is 64. On 4, circle B with endpoints of the diameter. So when you have the diameter and endpoints, you have to find the center first. So we're going to have to use midpoint formula, which is an average of the x's, average of the y's. So 3 plus -5 divided by 2, and 6 plus 2 divided by 2. That's going to be -2. -2 divided by 2 is -1. That's 8. 8 divided by 2 is 4. That's our center. Now, we can use our formula, plug it into that formula, to find our radius squared. So, it doesn't matter if you write r squared at the beginning or the end. R squared equals, I'm going to use that coordinate as my x and y values. We could use the other one as well. Either one works. So 3 plus 1 squared plus y minus, 6 minus 4 squared, because again, we're plugging in 3 and 6 for the x and y. 3 plus 1 is 4. 4 squared is 16. 6 minus 4 is 2. 2 squared is 4. Together that is 20. Again, that is r squared. So plug it into our formula. 20 for r squared equals x plus 1 squared plus y minus 4 squared. And that's our equation of a circle for that one. Now number 5 is asking us for not just the equation of a circle, but it's also asking us for the radius and center point. So on here, now I do have a typo here. So depending on how you read this, you could have read this one 2 different ways. This is really supposed to be a y. So that's my mistake. If you read it as a y, then we could first rewrite this. So we have x squared plus 4x plus blank plus y squared minus 6y plus blank equals 12 plus blank plus blank. Again, we're completing a square. That's why we have these blanks here, because we need a constant for each part of this. A constant for the x's, a constant for the y's, and whatever we add to that side, we have to add over here. Now, how do we know what to add on? Well, again, we use the formula b divided by 2 squared to figure this out. So this is the b value for the x's. So 4 divided by 2 is 2. 2 squared is 4. So we're adding 4. -6 divided by 2 is -3. -3 squared is 9. So we're adding 9. This side of our equation is 25. The other part, again, we have to change into our binomials that are squared. So again, it's square of the first term, which is x, sine from middle, which is positive, square root of the last term, which is 2. Over here, you have square root of the first term is y, sine from middle is negative, square root of 9 is 3. Now that we have it in the correct format, our center is at the point -2, +3. Our radius You have to take the square root of 25 because that's currently r squared is just 5. Then, like I said, this one I screwed up, so this is if you read it as y, which is what I meant for this to be. But if you did read this as an x and you already did all the work, I'm going to show the answer for that as well. Because if this was read as an x, that means that you've combined your like term with the other x value. So over here in green, I'm going to do the work as if we left it as is. So x squared minus 2x plus blank. Now you only have a y squared, so we don't have all the other stuff that goes with y, because that's going to be fine for the final format of our equation. Equals 12 plus the other blank that we had. What would we add on? Well, this divided by 2 squared, negative 2 divided by 2 is 1, 1 squared is 1, so we're adding 1 to both sides. Then we have, again, this side is currently 13. We still have the y squared. And then we have to do this side as our binomial squared. So square of the first term is x, square of the last term is 1, sine from the middle is negative. That's our equation. So our center, if you had done it this way, would be at positive 1, 0, and a radius square root of 13. Well, you can't square root 13, so you could either leave it as the square root of 13, or if you wanted to change it to a decimal, I'm not sure of the exact decimal there, but it would be like 3 point something, approximately 3. Now, on number 6 third are constructions. So this construction is a perpendicular bisector. I'm not going to write out all the steps. Again, we've done the steps are in your notes, the steps are in all the other videos. You have to be prepared for the steps to be slightly different anyway. So again, it's however you wanted to write the steps. I just wanted to give you the idea to do the steps because some of the questions on the test do ask you to look at steps, put them in a correct order. But again, every book is different. There's not one particular way to do a construction, so you have to be able to adjust. Same thing for the FSA. So, perpendicular bisector. From each of the endpoints, we're going to make sure that we put our compass on each endpoint. Make sure our compass is more than halfway of that length, and swing an arc to both sides of the segment. From the other endpoint, you swing the arc of the same congruent length to both sides. Both those points must be on the perpendicular bisector, and you can connect them. And now that is a perpendicular bisector. On number 7, the parallel lines. There's more than one way to do this construction, so I'm going to do this twice. I'm going to do it both ways. So the first way I'm going to show is the way that I showed in class, which is if you draw a tangent line, so not a tangent, a transversal line, because we're going to do it based off the properties of having a transversal and having certain angles. Oops, I drew that wrong. Certain angles congruent. So, you had something like that, right? Alternate interior angles are congruent, corresponding angles are congruent, and alternate exterior angles are congruent. So, I'm going with alternate interior angles. That's what I did in our notes, and that's how I'm doing this one. So, I'm going to copy an angle. So, I'm going to copy this angle, which if we're doing alternate interior, there it is. I'm going to swing an arc. Does not matter the size of the arc. Do both sides of my angle. Now then come up to the point up at the top. Swing the same arc to the alternate interior side. So again, I might have to make that slightly longer than I did. Now, you open your compass because we're copying this angle. You open your compass to the width of the angle. There you have that opening, so from here to there, and then we're going to go from here and mark off that same length so that the angle opening is exactly the same as the other. So we have this point. Now is where we're going to draw our line. So we have two parallel lines. So yeah, that's based off this idea. The other thing that you could do is based off the idea of a rhombus. If you think of a rhombus has all four congruent sides. And it's also a parallelogram. So if you use the lengths of the sides to make sure that it is a rhombus, any quadrilateral that is a rhombus is a parallelogram. So let's say we're just given the same things to start off. So I have my line, just like I had on the other drawing. And I have my point way up there off of my line. First thing I would do to create a line parallel using the idea of a rhombus is pick a random point on the original line. Then I'm going to take my compass and set it to that length. Now, just to exaggerate the point that I'm using this length, I'm going to actually swing the arc all the way from that point through to the other line. We could have just swung it down here, but again, I want to show that I'm using that length to swing it down here. So now, I have 3 points already for the vertices of my rhombus. These two are equally spaced, those two are equally spaced. From both of these vertices, I'm going to swing arcs out in front of the same length that I still have on my compass to find out where they would intersect. Swing it out there, swing it out there, and connect just these two. Again, if I was to draw all the lines that connect these points, it'd make a rhombus. But I don't need a rhombus, I just need parallel lines. So there's my parallel line through the point. Both work. You kind of need to know both. Well, you don't have to know this one for the test. You really have to know this one for the test. And this one would be beneficial if you want to make the construction shorter. So, circumcenter of a triangle. For the circumcenter of a triangle, you'd create all the perpendicular bisectors. Now, it doesn't say draw the circumscribed circle around the triangle. We're just looking for the circumcenter. So all we have to do is perpendicular bisectors. For this bottom line, I'm going to extend my compass so it's more than half the bottom segment. Swing an arc above and below. Same thing from the other endpoint. Using the same setting, swing an arc above and below. And then connect those points. From another side, I'm going to use this side. I'm going to do the same thing. Make sure my compass is at least more than halfway. Swing an arc above and below the line. Move it to the other endpoint. Swing the same arc to both sides. My arcs didn't intercept, so that means I have to make this one a little bit longer. So come back to my original one and extend it so it's a little bit longer. And I have the 2 points. Line them up. Draw it. So this is a perpendicular bisector. This is a perpendicular bisector. Where the perpendicular bisectors meet, this is our circumcenter. Now, if you were to do a circumscribed circle, it'd be an extra step. You take a compass, you do this, you set it to the length of one of your vertices, and you'd swing it all the way around the figure. Again, it only asks for circumcenter. You don't have to do the circle on this one. We did the circle in our notes. Incenter. For the incenter, we have Sorry, I got a text. All right, the in-center, I'm going to do angle bisectors. So I'm going to construct 2 angle bisectors. Again, doesn't matter what 2, so going from the top angle, I'm going to swing an arc. So it goes through both sides. From both of those points, I swing an arc out in front. Again, it could be the same length, it could be a different length, doesn't matter. Swing them out in front. Again, the only thing that has to be the same is the 2 lengths from each of these. Those 2 have to be the same. So, draw my angle bisector. And then, pick another random angle. I'm going to go over here to this angle. Swing another arc. Through both sides. And again, swing arcs out in front from both of those intersections. So that you can then connect vertex to that point. And that's another angle bisector. Where they intersect, this is our in-center. Now, if we wanted to do an inscribed circle, the in-center is equal distance to all the sides. So we'd have to go to one of the sides, and then we'd swing our compass around and have a circle inside the triangle. All right, the rest of these we're doing on the back. We're following the same process. Again, I would like you to do the steps, but if you just get all the constructions, that's fine. So let me get another piece of paper here, and we can go through each one of these constructions. So the next construction we have is copy an angle. So first you'd have to make a random angle. And then we're going to copy that angle. So in order to copy that angle, first start off by drawing a line or ray, because again, these are really rays. And then we're going to have to copy that angle onto this one. I'm going to take my compass, open it, so it will go through both sides, swing the same arc over here. Now I have to open my compass to the width of that arc we just swung, which coincidentally mine is already open to that. So go into this same point over here and swing the same little arc. Wherever it intersects, that should be the other line or ray for my angle. All right, so once you have copied an angle, yeah, that's copying an angle. Then we go to the next one, hexagon inscribed in a circle. Hexagon in a circle. We're going to start at a random point as our center point. Adjust our compass to whatever size circle you want to do. Uh-oh, something's in my way. Alright. Then, once we swing that circle, again, we're going to leave that same setting on our compass. Take a random point on the circle. Use that same length that was our radius to swing an arc to our circle. Then from that arc, swing another arc. Then from that arc, swing another arc. Then from that arc, swing another arc. And we go all the way under our circle until we're back at the original point. And again, if we did it accurately, it should be close to the original point. So now, a hexagon, you connect all the pieces that are consecutive, whereas if you're doing a triangle, you connect every other piece. So here, we're connecting all of these. I like connecting the ones that are parallel at the same time. And we have ourselves a hexagon inscribed into a circle. The next one on the list is a square inscribed into a circle. Square in circle. So, this one, it's important to make sure you label your center point because we're going to have to draw a diameter on this one. So, Swing our compass around. Draw any diameter that you want to through the circle. And then from the endpoints of that diameter, we're going to bisect this segment to create another diameter. So perpendicular bisector. So from each of those endpoints, we're swinging arcs of the same length. And we're connecting them through the center point. So we have another diameter. Where all of them hit the circle, we now have our 4 points. That should make our square. And we got ourselves a square. Alright. Next one, tangent line to a circle. Tangent to, oops, to. Well, we'd have to draw the circle first. And when we draw the circle, we're going to need a radius, so make sure you mark the center of the circle. So I'm going to start there. I'm going to swing a circle. Okay. And then we need a radius. But now we need more than just the radius, because the radius and the tangent are going to be perpendicular. So we're going to do our construction that makes a perpendicular line through a point on a line. We got a point on a line, but we need to have more of a line to the other side still. So I'm going to extend the radius past the circle. Our construction calls for us to swing an arc to both sides. Now we already have this set at the radius, so that goes through the center of the circle. We swing it to the other side. Hey, how's it going? So then, once we have those two from each of those points, swing an arc above and below. So it's like we're bisecting a segment, and you connect them, and that's our tangent line. Thank you. So that's a tangent to a circle. The next one on the list is a perpendicular line through a point off a line. Perpendicular line off line. So there's a point. There's our line. The steps for this one are the same steps for many of our other constructions. Same steps as an angle bisector, the same steps as creating an altitude. So we do this one a lot. Again, just the same basic steps, like our movements with our compass. So here, we go from the point, we swing an arc, so it goes through this line twice. From each of those points, you then swing an arc out in front where you just did. Again, you can leave it the same length. As long as it's more than halfway, it'll work. And connect. And we have our perpendicular line. Then, the next one we have is an altitude, which is the exact same construction we just did. If you draw any type of triangle, here I'm going to draw an obtuse triangle, because it's kind of important for your tests to know how to do an obtuse triangle. So we're going to do this, this, and this. Now, if I want to go from this point up top, I'm going to do the same construction, but before I start my construction, I need to extend this bottom line, because on an obtuse triangle, the altitude ends up outside. So I need to extend this side first. And then I'm doing the same thing I did over here. So I'm going to go to that top point. I swing my arc, so it goes through the opposite side twice. From each of those points of intersection, I swing my arc out in front. Again, I could leave it the same setting. I could shorten it if I want. As long as it's more than halfway, it should work. There it is. Draw my line, from the top down, and it's perpendicular to the opposite side. And that's my altitude. I don't have to go all the way out there because my altitude just goes from vertex to the opposite side. And then finally, copying a segment. When you copy a segment, you have a line given to you. So let's say that's the one that's given to me. Or I should say a segment given to me. And then I'm going to start off by drawing a line that's longer than my original. So I'm going to copy it onto that segment. For the test, I'd give you something to copy it onto. So we're going to start from here. I need to take the length of the first segment with my compass. So adjust my compass so I can see the length of that first segment. And then swing it onto the second one. So that now those two are the same length. And they are congruent. Therefore, I've copied that segment. That is it for that review. Again, there's also the review in the Springboard book. I'm going to post some of the problems from that. And that's it for the review. So, good luck on the test tomorrow.